starting that right now. Okay, it started. All right. My bad, I forgot to start, so we're good now.
It's all good.
The trig function, or the tangent function, what'd you say?
So like the first number that's in front of the trig function, so like the
The
y equals
amplitude?
-2. Like I can't remember like how to work that into the graph.
Yeah, so that just stretches or shrinks it.
Yeah.
That one can be confusing depending on, like, on tangent functions. That one's way confusing for me. On sine, cosine, or secant, cosecant. Actually, that's confusing too, but it just stretches the graphs vertically or shrinks. So like on the sine function, you know, if that amplitude were 2 instead of 1, it would be double the height of that wave.
Yeah.
Right? And it's the same situation with the tangent function. Like if the tangent function has that distinct, I don't know what shape you'd call that.
Yeah.
But it would just be, if it normally would have been like 1 high, you'd plot it 2 high if it were the amplitude of 2. So it really just changes, it just stretches this way by whatever amount given.
Yeah.
For each individual point, and then yeah, we haven't graphed too many of them, but yeah, hopefully we can figure it out. Well, should we try to do some of these just as a start, and then we can maybe look at some of the like the real test review and see if we can find a question that would be more applicable.
Yeah.
Okay. Well, we don't have a quiz, right?
No, you do.
For today?
Yeah.
Oh, okay. Guess so. All right, well, let's start with these, I guess. We'll start remembering as we do them, hopefully.
Yeah.
So 6 trigonometric ratios in simplified form, given A equals 3 and B equals 7. I'm trying to remember the trigonometric ratios.
Yeah.
So those are not trig functions.
Oh.
Hang on. Excuse me. Okay. Struggling to remember what these really are.
So, isn't this just all sine, cosine, tangent, cosecant, secant, and cotangent? Because I think we're dealing with a.
Oh, okay. Yeah, I was confusing something that we did a long time ago, but yeah, I think it's just is that like sine of theta equals opposite over hypotenuse,
Yeah.
that sort of thing, and then for cosine, tangent, cosecant.
Yeah.
So given a equals 3 and b equals 7, so um, is that from the function? I'm confused what a and b are supposed to be.
I think those are supposed to be the sides. So a squared plus b squared equals c squared.
Is this for a triangle though? Because I didn't think it was.
That's really the only thing that I can see it being.
Cool. Well, the key says nothing. There's no answer on the key.
Yeah.
Convenient. So I guess it's just supposed to be that obvious.
Yeah, I looked up 6 trig ratios and it's Google keeps on telling me about triangles and stuff.
Yeah. I'm so confused. Like, it's got to be sides, but which side is which?
Oh, well, third one C would have to be hypotenuse. Um,
Yeah.
A and B. Yeah, I don't know.
Does it? I mean, I don't feel like that's enough of a question to even start.
Yeah, not really.
Ugh.
Yeah, that's a pretty crappy question.
Yeah.
mean, should we skip that one?
Well, I don't. I was gonna see if I could find anything in the book.
Okay. Because I mean, if it is what we think it is, then we can solve it. But only if we have a little bit more information.
Yeah.
So we at least have the concept down, if it's the thing that we're thinking.
Well, okay. So let's say it is a triangle. We'll say A is adjacent, B is opposite, and then C is hypotenuse. Then C is a function of A and B, right? With the A squared plus B squared equals C squared thing.
Yeah.
So it's got to be um, square root of A squared plus B squared, right? And so we'll just put that in the ratio.
Yeah.
Is that what you were thinking?
Yeah, pretty much.
I think you may have said that, but yeah, okay. I think that's what we're supposed to do.
Yeah.
Because
So
that's the only thing that makes any amount of sense to me.
yeah. And so what I found to be C is square root of 58.
Okay. That's lame that there's no answer key.
Yeah.
Square root of 58 is what you got.
Yep.
Okay. I was seeing if there was any way to simplify that, but I don't see a way, so.
Not really. I the best that you can do, and actually no. When it comes to square root, there's really nothing.
Yeah.
You divide 58 by 2, and that gives you 29.
So I actually think, so what we did would be Pythagorean theorem, but I don't think that's what it's asking here. I think it's asking what trig ratio would you use to find C given A and B, right? And so rather than doing the Pythagorean theorem method, we could do yeah, like so sine theta of no, yeah, never mind. I think we're okay to have C. So that would help us find the angle if we knew this trigonometric ratios. I'm thinking out loud a little bit here, but okay. So sine theta equals 7 over root 58. Or cosine theta Okay, so in simplified form, wouldn't that mean that you need to get the square root out of the denominator too?
Yeah.
Okay.
So for like sine, it would be 7 square root 58 over 58.
Yeah. Okay. I think we're on the same page here then. So cosecant is root 58 over 7.
Yeah.
Okay, I think we're on the right page here.
Okay.
So let's look at number 2 now. Graph with all parts. Y equals negative tangent x minus pi thirds plus 2. Okay, well, looking at that, I see that there's no what is that called? There's no period. There's an amplitude of 1, phase shift of positive pi thirds, a vertical shift of 2
Yeah.
from the parent function. And the parent function, so the period would be the same since it's technically just 1. Yeah. Okay. So the parent function of the tangent starts at the origin and then does the squiggle from there.
Okay.
But since it is horizontally shifted to the right by pi thirds, it should cross. It should cross to the right, I believe. So the normal domain of a tangent function, I believe, is 2 pi. Is that, where's it pi? Do you remember? You got it down here somewhere. Did I not write that down? Yeah. So, no, it's pi. Okay. So for sine, cosine, secant, and cosecant, sorry, not the domain, the period.
Oh.
What am I, you know what I'm talking about? The period between like the start and end of a wave. So like if it's sine, that's one. I forgot the terminology, which is great.
Yeah, I'm pretty sure it's period, I think.
B is the period, but you use 2 pi over B or pi over B to get what? I'm sure I wrote it down somewhere. Okay, maybe it is period. Okay. I wrote down in my notes referring to that as period and referring to B as something different. So maybe it is just the period. Okay. So if we start at pi thirds, then we have to end at half pi past that. Our asymptote would be half pi past pi thirds, which is really 2 pi over 6. So 5 pi over 6 is our vertical asymptote.
I forget. How do you find the vertical asymptote?
It's just the start and finish of each period. I don't know if we technically learned how to get it, but
Oh.
I just know that's what it's called.
Oh.
Normally you just graph it and you would realize that the line never touches this, and it's called the vertical asymptote, but
Yeah.
Yeah. I'm just like trying to remember how you could possibly graph this without a calculator accurately.
So you just start plugging in x's that would match up, and it'll give you the other point. So like,
Well, how do you get the other point from tangent though? That's
so what you do, I already did it with the first one because it was easy.
oh
So you substitute x for pi over 3.
yeah.
So you got negative tangent times pi over 3 minus pi over 3 plus 2. So that comes out to negative tangent 0. Then you look on the unit circle. So 0 is 1 comma 0. And we already know that tangent is sine over cosine. So 0 over 1 would be 0 still. So then 0 plus 2 is 2. So your uh, y coordinate is 2.
Okay. At pi over 3, your y coordinate is 2.
Yep.
So that's our origin. Okay, so let's say 2 pi over 3. Let's plug that one in. Minus pi over 3 gets us yeah, this is where I don't remember. So tangent sine over cosine, I believe. Yeah. I'm gonna look back at some of my old graphs and see if I can remember. I'll tell you what, I'm probably gonna go through all of his videos before the test.
Huh.
Just remember everything. Okay, so I guess this is where we use the unit circle. So tangent of pi over 3 would just be looking at the unit circle, sine over cosine, which would be square root of 3. So negative square root of 3 plus 2. Yeah. Well, I get a value, but it's definitely not an easy one. Yeah, so I forgot that you use the unit circle once you get that parentheses down to a single number, then you just use the unit circle.
Yeah.
So 2 minus root 3 on a graph, I really don't know where that ends up. But
Yeah.
I'm guessing.
So just looked on the key, and they used 2 more points that I never would have really guessed. It would take a while to with trial and error, but from what it looks like they used,
7 pi over 12?
yeah, and then pi over 12.
What?
So hopefully they're not going to have a question as complex as that.
Yeah, and I imagine like you could just, well, let me think about this. Technically, I think this answer would be fine. I just don't know what 2 minus root 3 is. Although, I guess you might be able to do it backwards too and solve for x instead of y. Although, no, that sounds way harder. How would you do that? Yeah, I'll tell you, this key is not very helpful.
Yeah, not really.
Okay, either way, we can pretty much get the shape of the graph based on the period. And will look like Oh, I made that side bad. Yeah. You've seen the answer already. We don't need to get stuck on this. Okay. Let's do question 2. Maybe it'll, or part 2. So y equals -2 sine 2x plus pi minus 1. And we have to put it in standard form first.
Wait, isn't that standard form?
No, we have to factor the 2 out of the parentheses.
Oh.
Yeah, x has to be 1x.
Oh. Okay.
Yeah. So we factor that out and we get y equals -2 sine parentheses 2 parentheses x plus pi over 2 close parentheses minus 1. Then our amplitude is 2. It is vertically not shifted, what is that? Reflected over the x-axis. We have a period of, or a b that is 2, and so the period is 2 pi over 2, which simplifies down to just pi. Is this one coming a little easier?
A little bit.
Okay, I'm going to compare mine to the answer key. Yep. Oh, I drew it bad, but that's what I got. I completely just didn't even draw my line through one of my points.
Oh.
Which makes it look really nice. Okay. I feel pretty good with sine and cosine graphs.
Okay.
Tangent graphs are harder. And then the other graphs are harder too, but not as bad. Do you have any questions with this one?
No, I think I'm good.
So I guess let's talk about domain and range on these. So the domain of this one is going to be all real numbers, right?
Yeah.
What's that sign he used? It looks like an R with a weird line off the front.
Maybe that's for all real numbers.
It must be, but yeah. Anyways, it's all real numbers or negative infinity to positive infinity. That's always fair game.
Yeah.
And then the range would be from -3 to 1
Yep.
with brackets. The reason being is because we had the vertical shift downward by 1 to start with, and then an amplitude change of 2. So it's going to go down 2 from there and up 2 from there. That all makes sense to me. Does that make sense to you?
Yeah.
Okay. And then on that tangent graph, the way you have to report the domain is weird. So the range is all reals, right? That one makes sense.
Yeah.
If you look at that graph, like it's going to continue on forever in both directions. But then we have those vertical asymptotes, which he has dotted lines there, right?
Yeah.
And that means at that x value, there is no y value, right?
Yeah.
And so, yeah, he writes it down weird, but that's the proper way to do it. So we have to make sense of that because we're probably going to have to answer a question like that on the test, I'm guessing.
Okay.
Oh gosh. Yeah. Yeah, so the squiggly, I don't exactly know what that means, but then the x bar x does not equal negative pi over 6. So you'll just state one of the asymptotes, and then the plus pi k means since the period is pi, so every time you add pi to negative pi over 6, you're going to have another vertical asymptote where x does not equal anything. It doesn't show up.
Okay.
Does that make sense?
Yeah.
So x does not exist on the graph at negative pi over 6 and negative pi over 6 plus pi or plus 2 pi or plus 3 pi or plus 4 pi. And that's why there's that k there. And so, yeah, that'll just continue forever.
Okay.
Yeah. All right. Shall we move on?
Yeah.
Okay. Number 3. Find cosine theta given that sine theta equals 1/4 and theta is in the second quadrant.
I don't remember how to do this.
In the second quadrant? That doesn't make sense. Find cosine theta given that sine of theta is 1/4. Oh, that's, never mind. Okay. I'll tell you what, this is going to be extra tricky when we don't have the unit circle on the test.
Are we not allowed the unit circle?
No, I don't think so. I mean, he says to have it memorized, so I'm guessing we're not supposed to use it. Which is great.
Yeah, that's stupid.
Yeah. I mean, there's a lot of repetition on it when you look at it. It helps as a visual.
Yeah.
Okay, so okay, so if sine theta is 1/4 and it's in the second quadrant, then that means it's gonna be right around here on the unit circle
All right.
because that's 1/2 up right here. So 1/4 is gonna be half of that y distance, which yeah. So cosine, whatever it is going to be close to -1.
Okay.
I'm trying to remember how to do this. We have sine, we need cosine. Man, I do not remember how to do this.
Yeah, same here.
I mean, it's when dealing with the numbers that aren't on the unit circle. It's just a million times more complicated. Oh, okay. Okay. I think I know it. I think. Maybe not. Okay, yeah, I remember how to do it.
All right.
So, the fundamental identity of trigonometry is this. Where is it? Right here. Sine squared alpha plus cosine squared alpha equals 1.
Okay.
And so, I don't know if you can still see that. But yeah, we can use that to get cosine from sine.
Okie dokie.
So what we have to do is first we will say sine theta equals 1/4. And then we have to square it to get sine squared theta. And so we'll square both sides. We get sine squared theta equals 1/16, right? If you square 1/4, you get 1/16, right?
Yeah.
All right, so our sine squared theta equals 1/16th, and then we just plug that into the function as sine squared theta, and then solve for cosine theta. Does that make sense?
Okay, so it's going to be 1/16 plus cosine squared theta equals 1.
Yes, and then solve for cosine theta.
Okay. Okay, so what do you do afterwards?
Um, did you get it all the way down to cosine? So did you square root the cosine squared theta on both sides?
Oh, no, I didn't.
Yeah, so get it down to cosine theta. So I got root 15 over 4.
Yeah, that's what I got.
Okay. Yeah, I mean, that's really not too bad. You just have to remember when to do trig and when to do algebra, I
Gotcha.
guess. All right. Let's move on to 4. Okay. Find without using a calculator cosine of that. Okay. So the inverse sine of root 3 over 2 is is it pi thirds or 2 pi thirds?
Uh, it's going to be pi over 3.
Do you remember why it's not going to be 2 pi over 3? Because on the unit circle, like that, both of those um, areas give a sine of pi over 2, or of root 3 over 2.
So the arc sine, it's going to be in in that range of uh,
Oh, you're right. Good call.
so in that first range, like all the way from
Yeah, quadrant 1 and 4. So negative pi over 2 to positive pi over 2.
yeah,
Good call. Okay, that makes sense. I thought there had to be parameters.
yeah.
Okay,
So it's
perfect.
going to be pi over 3, and then you just times that by 2, so you got 2 pi over 3, and then you just find cosine of 2 pi over 3, which comes out to negative 1/2.
-1/2. Cosine of 2π/3. Okay. Cool. So far, so good. Just gotta remember stuff. All right, let's do this quiz. Okay, so answer the following questions as a group. Group leader will submit one copy for the group. Blah, 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 blah. Question 1. Identify the length of the period for each of the 6 trigonometric functions. This is good practice.
So now, didn't you mention that before? Like 4 of those is pi, and the other 2 are like 2π.
Yeah. So the length of the period. I can't remember the reasoning anymore, but I do remember that sine and cosine are sine, cosine, secant, and cosecant are 2π. Tangent and cotangent are pi.
So wait, the first 4 that you mentioned, which one were those? They were pi or 2π?
2π. So sine, cosine, secant, and cosecant are all 2π.
Okay.
Okay. And to go along with that, don't forget that like 2π is the assumed period given that b is 1. If b is something else, you divide 2π by b or pi by b.
Oh, okay.
From that what's it called? From that transformation function that we are given, the standard form.
So, wait, which number is b?
I'll show you. In this guy. So f of x equals a sine parentheses b parentheses x minus c.
Okay.
C plus d. So b is your period, and you divide 2 pi by that number to get your period.
Okay.
So I wrote it down here as well. So 2 pi divided by b is your period for sine, cosine, secant, cosecant, or pi divided by b for tangent, cotangent.
Okay.
Okay, so the next question is identify which quadrants each of the 6 inverse trigonometric functions are defined. So this is what we just barely talked about.
Yeah.
This is not quite as straightforward though. I mean, it is, but it's more confusing for me. So, cosine and secant are from 0 to pi on the unit circle. So quadrants 1 and 2.
So you said cosine and secant? Those
Yeah.
were okay. I remember we just talked about arc sine, and that was from quadrant 1 to quadrant 4.
Yes. I should put arc in front of them in my notes. I put inverse. Yeah, so quadrants 1 and 4 for arc sine, arc tangent, arc cosecant, and arc cotangent. So a better way to look at that is this right here, looking at the unit circle. So arc cosine and arc cosecant show up on the top half of the unit circle, which is from 0 to pi, or quadrants 1 and 2. And then down here, arc sine, arc cosecant, arc tangent, arc cotangent on that part of the unit circle.
Oh. Okay.
Or from negative pi over 2 to positive pi over 2, aka quadrants 1 and 4. Does that make sense?
So
All
there's
right.
like no function that goes from like quadrant. I
3.
don't know. Yeah, quadrant 3 at all.
No inverse function.
All right.
Yeah, I'm not quite sure how that works, but hey, that's what I learned.
I'm fine with that.
Yeah. Okay, so number 3 now. Graph y equals 1/2 cosine pi over 2 plus 3 pi plus 4. And we always start by getting x alone, right?
Yeah.
So let's do that. All right, so, oh, I guess I'll do that first.
So just so I'm getting this right, so it would come out as negative 1/2 cosine parentheses 2 cosine x plus 6 pi ending parentheses plus 4.
I think it's parentheses 1/2 parentheses x plus 6 pi.
Parentheses 1/2.
Yeah. Because if you multiply 1/2 back in, then you'd get 1/2 x and 1/2 of 6 pi.
Oh,
Right?
okay.
Yeah, I had to do it both directions to make sense of it. Okay, but now we can identify our transformations.
Okay.
So it is reflected over the x-axis, right?
Yeah.
A is 1/2. Remember, A always needs to be positive. If you put a negative number for A, it's going to be wrong.
Okay.
So our B is 1/2, which makes our period what?
Oh, 1/2. Wait. No. Uh, maybe 4 pi. Wait.
Mm-hmm. Yeah,
4 pi.
I think so. And then we have a horizontal shift, or what is that called? Is that it? Phase shift, that's what it is. Phase shift to the left, 6 pi. That's a lot. And then a vertical shift upwards of 4. Okay?
Yeah.
And now we graph it. Okay. So our period's 4 pi. Okay. Which means we start clear out to the left and it's really stretched horizontally. And it's shrunken vertically. I hate doing graphs on normal paper. Graphing paper would make it way easier.
So what points are we using for this one?
Well, if we look at the parent function of a cosine, ooh, I've got to think about this. If it's flipped vertically across the horizontal axis, it doesn't flip it like, if this is y equals 0, it doesn't flip it like this, right? It just flips it like this,
Okay.
right? Versus this.
Yeah.
So yeah, it's got to be. Man. Well, I guess let's plug in points. That's going to be the best method.
Okay.
Let's start with x equals 6. It's a good place to start. Or 6 pi, negative 6 pi.
Yeah.
That's 0 times a half is 0. So cosine of 0 equals Hang on.
So that would come out to 7/2.
7/2. I'm confused what to do with the cosine here. Because we get cosine of 0, right? But why do we not do anything with that? Because cosine of 0
Is 1.
is... I'm confused.
No. So are you saying, like, what is cosine of 0?
Yeah, so like we solve everything in the parentheses and get 0, right?
Yeah.
And
So
then why do
cosine
we just ignore cosine at that point?
so cosine of 0, if you look back onto the unit circle, you go to 0, and then it's the x coordinate at 0. So that's 1.
Sine is 1 at cosine of 0. Right?
If we're looking at cosine, it's going to be the x coordinate, so it's going to be 1. So then you take 1/2, negative 1/2 times 1, which is negative 1/2 plus 4.
Holy crap. I don't know why this is not computing for me. I mean, I expected something around there to be the answer, so it kind of makes sense.
Yeah.
You said 7/4?
7/2.
7/2, okay, yeah. Which is 3.5. All right, let's do another one and maybe it'll make more sense.
Okay.
So what is our period is 4 pi, which means we kind of need to do every pi then. So let's do 5 or negative 5 pi. To cosine of pi. Oh, okay, I just made sense of what you were saying.
Oh, okay.
Yeah, you're right. Oh, so cosine at 0 degrees is what you were
Yeah.
referring to. Okay, I was thinking cosine of 0 and then looking at this spot where cosine is 0, and I was way confused. But this is what the number we needed to look at. Right here. Sorry. Yeah. Okay. Cool. Makes sense now. So cosine of pi over 2, which is 0, plus 4.
Alright, so I got 5 points so far.
Okay, I'm not quite there.
Okay.
But I definitely see the pattern. So 2 pi is going to be 7 halves again, right?
Yeah.
And pi is going to be 4 again, if we follow the trend.
You mean negative pi? Or
Sorry, negative pi. Yeah.
so negative pi, that makes it 5 pi times 1/2. That's 5 pi over 2. Uh, I don't know what 5 pi over 2 is, though. I don't see that on the unit circle.
What? I'm.
Uh, so when you plug in,
Oh, if you did positive pi.
or no,
5.
I did a negative pi,
Yeah.
and so it comes out as cosine of 5 pi over 2
Yeah,
is,
so what happens is 5 pi over 2 is greater than 2 pi.
okay.
So it's basically all the way around plus pi over 4.
Oh,
Yeah. Does that make sense? If it's greater than 2 pi, so like 5 pi over 4, basically, if the denominator is 4 and the numerator is greater than, hang on, did I say 4? If the numerator is over double the denominator, then it's going to be more than all the way around, right?
yeah.
So just double the denominator, subtract that amount from it. So, right, 2 doubled is 4. Subtract 4 from the 5 and you get 1.
Oh,
1 pi over 2. So it's all the way around plus pi over 2. Sorry, I said pi over 4 the first time, but
oh,
um, I made that sound way confusing. A way to understand that better is just subtract the 2 pi off. Yeah. Yeah. I need to draw my line here on this cosine graph we just made.
okay. So it would be pi over 2 then.
Yes, it'd be the same as pi over 2.
Okay.
Yeah.
Okay.
The cosine and sine would be the same as pi over 2.
All right. So that means
Because
0.
it's all the way around back to that same point. And so, same thing if you were to say like 9 pi over 2, that you'd get back to that same point.
Yeah. Okay.
Or 13 pi over 2, same point.
Okay. So that means that is 0. So 0 times negative 1/2 is 0 plus 4 is 4. So yeah.
Okay. I'm comfortable with number 3. Let's get going on number 4. I need to go to bed.
Yeah, I'm freaking tired, man.
I
It is a
was really hoping we'd be able to get through this fast since we've already done this stuff, but
yeah.
I
Well,
just
so tangent 7 pi over 6. So on the unit circle, uh, so it's sine over cosine. Boom, boom. So it's going to be positive square root of 3 over 3. Uh, Cosecant.
so yeah, tangent is sine over cosine. Okay, I agree with that.
Okay. Um,
I have to write this out in full so that the teacher will give us credit, but
ah, gotcha. Yeah.
negative. Okay, so B is cosecant.
Yeah. So I forget. Is cosecant 1 over sine? Is that what that
So
is?
cosecant should be the inverse of sine, right? So sine is, am I thinking of that right? Let me check. Yeah, 1 over sine theta.
Okay. 1 over
So
sine.
the inverse of sine. Yeah, that's something that I have to drill in my head because sine starts with an S and secant starts with an S and cosine and cosecant start with a C, but
Yeah.
it's not, they're not correlated. They're actually the opposite of what you'd think there. So sine is the inverse of cosecant and secant is the inverse of cosine.
Yeah. So this one would be square root of 2, I believe. So going the negative route, negative 5 pi over 4 is the same thing as 3 pi over 4. The sine of that is square root of 2 over 2, so 1 over the square root of 2 over 2. So you flip that, that's 2 over square root of 2. Get the square root out of the denominator, so you times top and bottom by square root of 2 over 2. That's 2 square root of 2 over 2. Simplify it, it's square root of 2.
So 2 root 2 over 2, which equals just square root of 2, right?
Yep. Yep.
Cool. Agreed.
See, arc sine of negative square root 3 over 2. So that's in quadrant 1 to 4. So the sine of that is negative square root 3 over 2. So that lines up with 5 pi over 3.
Two arc sine. Is that negative pi thirds?
Oh, wait, yeah. Because we're. Wait. Yeah. Yeah. I think so.
Man, I don't have a clue how to show my work for that.
Yeah, because since it's arc, it would come out as the negative version of
Yeah.
5 over 3. So, yeah.
Well, it's not since it's arc, but it's since it's. Oh, wait, hang on. I don't know, actually.
So maybe it is 5 pi over 3.
I don't remember. Um, no, I think it goes again to that 5 pi over 3 is technically correct, but it's not within our parameters of, remember this guy, wait, this one,
Yeah.
right? So negative pi over 2, which is down here, to pi over 2. So you actually would need the negative version because 5 pi or 5 pi over 3 is not in here. It's not in those parameters.
Sure.
Yeah, I mean, that's just 5 pi over 3 technically would be correct because it gets to the same point. But then again, we could go all the way around the unit circle as many times as we want and hit that point every single time and it would be correct. And that's why they limit you to those parameters with that we defined right here.
Yeah, the thing that I'm wondering about though is 5 pi over 3 is in that parameter.
It ends up on the same location on the unit circle, but it's not within, like if you look at it on a graph, think of a graph. So I'm going to draw a graph, a rough graph here. 0. Okay. So our parameters are negative pi over 2 to pi over 2. Sorry. So negative pi thirds is going to be somewhere around there. which falls in between. 5 pi over 3 is going to be somewhere clear out here. So it's not inside this range.
Okay. Yeah, okay. I think I get what you're saying.
Yeah.
The range isn't from pi over 2 to 3 pi over 2. It's pi over 2 to negative pi over 2.
Yes.
Okay. All right. Got it. It's negative pi over 3 then.
uh, the details. Okay. It makes sense now. For some reason, I knew it had to be negative, but I didn't know why. So my instincts kept me safe on that one, kept us safe on that one. Okay, let's do this last one and be done.
Yeah. So, square root of cosine over sine.
This is one of those where you have to think backwards.
Yeah. So I believe it's negative pi over 6. I think.
So negative root 3 over 2 cotangent is sine over cosine. I remember it's cotangent. Is cosine over sine. Which means root 3 over 2 must be cosine, which is an x function. Two. Did you say 5 pi over 6?
No. I said a negative pi over 6.
Okay. So technically, if you do the math, both of those come out, right? But now we have to remember our parameters for cotangent and tangent, which are the same as sine and cosine, or the same as sine and cosecant. So you're actually right, I'm wrong. Which is not right. Negative pi over 6 is what you said?
Yeah.
Yeah, so I couldn't quite remember there, but we've got to memorize this. This is going to kill us otherwise. But yeah, so tangent and cotangent, or inverse tangent, inverse cotangent, falls in this range,
Yeah.
which your value of negative pi over 6 would be right about there. Where
Yeah.
my value would have been over here, which falls
Okay.
outside the range. right?
Yeah.
So parameters, you got to remember those. I've got to remember those. Okay, well, we're done.
Awesome.
Well, now that we're remembering things, I'm at least a little less nervous for the test.
Yeah.
But I don't know. I'm gonna have to sit down and do some studying still.
Yeah. Same here.
Lame. I feel like this would be a lot easier if we just had a lecture.
Yeah.
Campus.
So too.
We're stuck to figure out things for ourselves, and once we get to new material that I haven't seen before, it's gonna get really tough. All of this I have done. It's just been years.
Yeah. Same here.
So hopefully new material won't just eat us alive. But I
Yeah.
guess we'll find out. Alrighty, well, I'll let you go. I'll get
Okay.
this stuff turned in again and we'll move on.
All right. Sounds good. Hopefully the URL works this time.
Oh yeah, I'll try to get those submitted correctly too. I've got to find the correct URL for those. I'm really not sure how to do that, but
Yeah.
I'll figure it out.
Okay.
All right,
Well,
well, thanks, Tyler.
yeah. You have a good night.
You too. We'll
Okay.
see ya.
Bye.